Cool, so I think we can get started as it's 11 o'clock now. So welcome to our talk, Multiplayer Misadventures. My name is Gabriella, wannabe Pokemon master and developer at Chaos Theory for over 4 years now. Here with me is one of the founders of Chaos Theory, Will, who is also our technical director. He loves tea but is allergic to prawns, so don't try feeding many shellfish. Today we'll be taking you through the life cycle and learnings which we have gleaned over the past 12 months whilst working on a mobile online multiplayer game made in Unity. We hope to cover some of the steps that we took, the challenges we faced, and the solutions that we discovered, and then hopefully wrap up with some tips for anyone thinking about doing the same for themselves. We won't be covering too much of the actual individual components that make up the framework for multiplayer games today, but instead just sharing with you all our overall experience of us making this game. So we hope that you can enjoy. So for those who haven't heard of us yet, we are Chaos Theory. We are a 23-person team all based somewhere in Australia, with our main base of operations being in Sydney. We've been making games for over 6 years now and have hundreds of titles under our belts, ranging from small activations to larger projects. Along the way, we've worked for the likes of Samsung, Telstra, and the Australian government, to name a few. So where are all of our games then? Well, Chaos Theory is currently a client services business, meaning that many of our projects are unfortunately not publicly available, as they are often being used behind closed doors. That said, in total, our games have actually been downloaded over 70 million times on platforms including PC, Android, and iOS, which is pretty cool. But less about us and more about the game that we travelled down to Melbourne to tell you all about.
So this whole talk is within the context of our first multiplayer mobile PvP game, Galactic Islands. So I'm going to tell you a little bit about that. Galactic Islands is a classic base building game with a real-time multiplayer twist. You can set up your buildings and defenses in your own time, select your favorite hero and your army, and then jump into a multiplayer battle where you challenge another island head-on in a war of total destruction. The first half of it, which you can see on the screen at the moment, is the single-player game loop. This is the base building side of things. You're going to be building different buildings here, optimizing your layout. You've got defenses, you've got utility buildings, resource generation buildings. You can unlock these buildings, upgrade them, and sort of do a few things there. You'll be spending the majority of your resources in this part of the game as well. And it's important to note that this is generally time-gated content, so some things may take minutes, hours, or even days to complete. Once you're done with the single-player side of things, move on to the multiplayer side of things. You are matched with someone of a similar skill level to yourself, and your islands are smashed together to form the battlefield you'll be playing on. After this starts, you'll gain real-time control over your hero, your base defenses will come to life, and you'll be able to deploy your army to out-strategize your opponent. The goal here is really just to destroy as much of your opponent's base as possible in a short 2-minute time limit. So what are we calling the genre of this game exactly? Well, we're going with cross-platform, mobile, real-time, player versus player battle game, or CPMRTPVPBG for short. Hopefully that's nice and rememberable. Anyway, enough stalling. It's time to dive into the life cycle. We've broken down the development so far into 4 main segments. These are by no means traditional software development lifecycle steps, so bear with us. We've watched Galactic Islands grow from conception through to maturity, and have settled on a much more human lens that we will be viewing it through. Let's start with the early development. Our project, is much more of a concept than a reality at this stage, an idea in our heads or a bump in our metaphorical bellies. We will aim here to cover some big pre-production wins, starting with what we researched and then moving on to some prototyping. So where did we begin and how did we start? Well, it all started with a bit of chaos. All good games usually start with a healthy amount of pre-production, and Galactic Islands was no exception. Here's a bit of what ours looked like. We started out by thinking about what worried us most in the project, and for this was the backend and the networking for us. This is going to be a big project. We had limited experience working on network multiplayer games before, and we knew we needed a solution that was going to serve the needs of the project, but also serve the needs of the team as we were learning this. We started out by noting down what we did know. This meant coming up with a list of our requirements. For us, this was cloud saves, server hosting, guild support, and the support for real-time multiplayer. Once we knew what we did know, it was time to move on to the unknowns. We put together a huge amount of research documents detailing all of our options out there, trying to find a good idea of what was on offer. For the real-time multiplayer, we looked into things like Photon, Mirror, Dark Rift 2. For the back end, we looked into things like Firebase, PlayFab, GameSparks, or even rolling our own custom one, which I don't think we were too keen on. I think it's really important here to try and be thorough, and hopefully you can see that we were along the way. Diving into these and figuring out their little idiosyncrasies and the nuances they have to offer can definitely save you weeks of time down the track as you find things that service can offer, or maybe even that they can't offer that you were expecting it to. I think even if, there's a huge amount of overlap with these services. They are ultimately competitors, and they have a very similar base offering to each other. So deciding on which one is the best can be quite difficult. Eventually, I do think you need to lock in something and roll with it. I think that's really important. A rewrite of our game down the track using another framework would have been incredibly costly. There was the idea floated early on of why don't we just make it so we can swap PlayFab with Firebase later on, but I think doing that locks yourself out of using the nuances of those services and really starves you from getting the most value you can out of the chosen service. Even if you are pretty sure of the tech you're using, maybe you've used some of these before, I think it's a good idea to get a refresher on what's changed in the other tools. If you are locking in with something like we did, it's good to know ahead of time what it will provide you with out of the box and what are going to be your major technical tasks to implement. In the end, we decided on using Firebase for our cloud functions, PlayFab for our backend and server hosting, and Mirror for our real-time multiplayer framework. So in the end, there was a little bit of order to the chaos. Let's not go to the next slide. Here we go. Now that we knew what we wanted, we spent a bit of time confirming our decisions. We put together a tech demo representing a really basic model of what we might need in the future. As you can see, this was very much a tech demo. We were using Unity out-of-the-box 3D assets, Unity UI. There was nothing fancy going on here. And I think it's really important not to try and mix your design demos with your tech demos because it can get really messy quickly. This demonstrated state synchronization, building and unit synchronization, and even a technical challenge we knew we wanted to support called state mirroring, which is where you can see here both players kind of get the feeling that they're playing as player one. They're both playing bottom to top. They're both the blue player, but are actually seeing a mirror of what each other is seeing. I think the way that we approached this was very key to its success. This wasn't a part of the main project. This was throwaway code. We were able to be really experimental here. There weren't rigid design requirements. Anytime we kind of ran into a design issue more than a technical issue, we moved on and focused on what was going to be the next important technical task to sort out. We had a clear goal for this prototype as well, which is really important for any prototype. We wanted to know that this tool would suit us, and we were able to figure that out. And finally, it was time boxed. I know when you're learning a new tool, you can get carried away in the excitement of understanding it, but it's really important to set yourself a time and stick to that. This process allowed us to confirm a huge amount in just a few days. We played around with the deployment, server hosting, some mirror development practices, and really got a good feel for how the tech would be working for us. Definitely, though, do not forget to document your results once you've had that chance to play around. If you're working with a larger team like we were, you want others to be able to glean the same insights that you've been able to glean from this process. Don't hesitate to spend even a day or two writing stuff down, putting documents together. We had a solo dev working on this. They were able to move really quickly. They had no one stepping on their toes or anything, but eventually they were going to need to share that knowledge with 5 or 6 other devs. So putting that documentation together really helps with onboarding those people and skilling them up in the future. This process also highlighted some questions we weren't even thinking about at the start. The biggest one was how to ensure our iteration time was as low as possible. Creating multiple clients and a server, uploading those to PlayFab every time you made a change to some server code, which is out of the question for us. And so we honed that down and made it so that developers could validate their builds and their changes in less than a minute, which was fantastic. On the other side of prototyping, we're back in familiar territory again. We've moved away from networking. We wanted to confirm that our PvP battles would be fun before we spent a year working on them. Now, we had limited experience working in networked multiplayer before. We had lots of experience with single-player games, as you've heard before. There was the temptation early on to take that tech demo you saw in the previous slide and just build upon it, turn that into our design demo. We'd already done the hard work anyway, right? But I think that really would have crippled us. It's important to play it safe when you're doing a design demo. Stick with the things you do know so you can move quickly and validate your assumptions as fast as possible. We wanted to be able to distill a version of the game that we could play that would allow us to validate that the game was fun, because we wanted the game to be fun, of course. We had thankfully worked with a plugin recently that allowed you to create virtual mice and link them with multiple input devices. So in the midst of the 2021 lockdown that I'm sure everyone remembers so well, we had people with their roommates and their partners isolating, plugging 2 mice into the same PC, playing this game on the same screen. We essentially just created a couch co-op game, but using mice instead of controllers, which really allowed us to capture that touch input that we were going to be going for on mobile down the track. We eventually got to do a playtest, and the game was fun, which is fantastic. I think it's really important to have this idea ahead of time of where you're going. We were able to generate this team vision. If we were going to be spending this year working on a project, we knew that we were going towards a game that was going to be fun. And that generated a huge amount of momentum and motivation amongst the team and put us in a really good starting point early on. We iterated a little bit on the prototype, moved on pretty quickly to the main game from here. Overall, we left pre-production feeling pretty confident that we knew which direction we were going, even if there were still a lot of unknowns. The stage had been set, Galactic Islands was taking shape, but I'll hand back over to Gabriella now as the project starts its wild journey through the great unknown.
Thanks, Will. So yeah, after teaching the project to walk, talk, and not reach for the sharp pointy things on the top of the kitchen counter, there comes a time in a parent's life that they all say they forget, but secretly hold over you for the rest of your lives. The awkward teen phase. Here we'll be touching on some of the early struggles that we face, such as with our saved data and what the hell the client and the server even are anyway. So after being happy with the results of those prototypes and the decision made for the game's main pillars from that initial design playtesting session, we couldn't wait to actually get our hands dirty and start making the damn thing. Quickly, the meat and bones of the features we had researched were coming together, and we could even build buildings on the island using a repurposed grid system. And look, even some glowing yellow bricks. In-game currency was already being handled through PlayFab's economy system, and we even had in-app purchases configured really early on both of our platforms. We could also already match with other players using PlayFab servers, and pairing this along with the art and the UI, we actually had something that looked like, well, a game. So after all that love and care, you would think that there would be no hiccups, right? Well, think again. Our game was nowhere near perfect, but neither should we have expected it to be. And our problems really began when we started to work on the multiplayer side of things. Even from all of our research done, making this multiplayer game was just so much more than we had anticipated it to be. This project was a whole new beast which we had never experienced before. The expectation was actually that the architecture would be pretty linear. We'd be able to pull our values down from some form of remote configuration into Unity, and then through the use of Firebase Cloud Code functions, communicate with PlayFab and its servers. But there were just so many integrated and intertwining systems that came into play when implementing some of these features that we needed, such as leaderboards. We needed to use PlayFab's statistics system, its groups for guilds, and then we had to rework all of our in-app purchases to work with its catalog and bundle items. We were actually really lucky that PlayFab could handle all of this, but then we also then had to tackle the nuances of integrating these systems themselves and making them work not only with Unity, but also with each other. And then finally, funneling them all through Firebase Cloud Code function calls so that players couldn't access all this information directly within the game. These unforeseen intricacies led to constant problems with matchmaking, even as the project became more established and stable. Integral systems which work perfectly when just in the island scene were now made redundant when brought over to multiplayer, and save data, which randomly reset the player's island when returning to top that off. This project was just a child who had found the alcohol cupboard, and before they could tell what was happening was throwing all over grandma's priceless antique rug. It was really demoralizing, and when we got together to play test and people's islands were resetting or the tutorials were starting from random places at random times, even after they had already completed it, we knew that we had a lot of wild childs to wrangle. So yeah, we needed to make some adjustments. We had to face our problems and find solutions for them. We couldn't just yeet our child out of the window. We had to rethink some of the ways we were dealing with these foundational systems, and some of the things we'll touch on today is how we changed the way our data was being saved, how we changed values not only syncing on the server but also on the client, and then finally how we had to safeguard against potential cheating. We faced a layering number of issues when it came to the game's save data, and went through many iterations of how this data was actually being stored until we got it to a stable place. We ended up with a system that was far from what we had originally researched. Initially, we chose entity objects, which is what PlayFab recommends in their documentation, and after implementing it and using it for a little while, it was perfect, until this data reached over a kilobyte. The player's save data was already reaching its full capacity after only building their third building on the island, so we just knew that this wasn't going to be a feasible option. So we then scrambled back to PlayFab's documentation and went with the next suggestion, entity files. And yeah, this seemed like a great idea too. Until we realized the implications of making these multiple API calls to not only save data, but also retrieve it. This was a really slow method, and it led to us having multiple write conflicts really early on. And so, yeah, this was just a really unreliable option. So we went to PlayFab's roots and actually landed at their legacy system, titled player data, where we could save data as JSON strings in key value pairs. Now, I know what you're all sitting there thinking, why didn't we just go with this in the first place? Well, as we've mentioned, we're pretty new to this. We'd never made an online multiplayer game before, and so we trusted what PlayFab's documentation was trying to tell us. But don't you just love it when documentation is out of date? Though this titled player data was quite hard to retrieve, and we needed to make some workarounds to make it work with our Firebase Cloud Code function calls, it was actually really worth eventually going with this option in order to make sure that all the players' data could be as stable as possible. So yes, our save data went through many personalities. Its emo phase, and I don't want to talk about its believer phase. But at the end of the day, luckily, is that development was never set back when it did. We decided to have a whole sprint dedicated just to refactoring some of these foundational systems before adding more features onto an already pretty feature-heavy project. This meant that development could still continue at a consistent pace while one of our devs worked tirelessly on getting this working. And as new features and content wasn't being put in, they could merge us all back in without a hitch and not stepping on anybody's toes. It also really helped though, and I really want to stress this, that we found this issue early and decided to fix it that early on, as we knew that we had some major changes to make before this project got a major makeover. It's okay to make mistakes. Everybody has those days. But it's the catching them and fixing them early that's the real tricky part. Before I get on to value syncing, we should probably tell you a bit about remote procedure calls. For those who don't much about them, because I certainly did it when I started working on this project, network systems have ways to perform actions across the network, which are called remote procedure calls, or RPC for short. There are two types of these RPCs in the network system. Server RPCs, which are called from the client and run on the server, and then we have client RPCs, which are called on the server and run on the client. The client here is essentially the requesting program, and the server your providing program. But I'll get to some examples so that this can all make a bit more sense. So with value syncing, which we use player power here as the example, which is pretty much the currency that players use in battle to spawn troops. As you can see, it's reflected in the pink power bar on the screen. This value updates over time. Originally, this was only being tracked on the server and sent to the client through a client RPC to essentially just tell the client and update it to how much power the server now had so that UI could then match up. As this call could sometimes be delayed, this made the bar look really janky, and more times than not it would be jumping all over the place when updated, as the message from the server took actually longer to receive than expected. This method also really limited us on how detailed and accurate we could be with the player's power, as we could only send it whenever it reached a whole number, as RPCs are costly. Literally, RPCs are costly. They cost you money, as you have to pay for the data transfer to and from the client. So anytime you call something, you basically have to pay PlayFab for it to travel across the network. These RPC calls, like most functions, also have a general impact performance on your game. Just imagine them as bigger, chunkier functions that slow down the server every time that it's called. And if the server lags, everyone lags, and then nobody's going to have a fun time. As you can see here, we also have two players playing in real time. And so these calls need to not only be sent out once, but twice. Once for each player, which further extends the amount of time and performance impact that these calls have, as everything is now doubled. So you need to make sure that you're really thinking about how and when you're using these calls so that they don't come back to bite you, or that they don't throw up all over Grandma's rug. So, how did we solve this? Well, first off, we knew that we wanted to set this value on both the server and on the client, so that the value could be read for client-side purposes like the UI, whilst also still being validated server-side. We accomplished this by essentially running the same coroutines on both client start and server start, so that they could run in tandem. But realistically, the server and the client never really run at the same time. So you can't just run these coroutines and hope for the best. There's a lot of factors that come into play when trying to track these values on both. We needed to make sure that the power was synced regularly on the client to match that on the server, so that any discrepancies made client-side or lag server-side would eventually be accounted for, as otherwise we would still have the same problem as we did before. So that we weren't sending these RPCs every frame as well and racking up chaos theory massive bill, we did this by running another coroutine, once per second, which force synced the client power to match that of the value of the power on the server. As you can see in these two functions here, the only difference between these two is actually just the start of the sync power coroutine in the server battle start. Our UI bar now looks super smooth compared to what it was like before, as there was now no delay in its values updating. The UI could update straight from the client values rather than needing to wait for the server. This meant that we could now store the power value as a float as well instead of an integer, and could do some funky stuff like showing the real-time value of the power updating in the background. More importantly, this gave this value the security it needed so that players couldn't cheat. Which segues me into safeguarding against hackers. Though the power on the client fixed a lot of our visual issues, all values on the server should actually be your source of truth. And so with power, anything that tries to spawn or be spent using this value needs to be checked against this server value. But like in most cases, we need to read and show this expenditure within the UI itself, otherwise the players there's no idea what's happening. So, with troops, we had to make sure that the player could not only afford to spawn a squad with power, but also that the location they tried to spawn them in was verified on both the client and the server. What you can see in this GIF here is real time of a player moving the troop along, and the red cross will come up if, when checked on the client, they can't spawn it there. But then we needed to make these checks on the server afterwards, and then send this back to the client so that we could tell whether it happened successfully or unsuccessfully. We did this through the use of a server RPC, which in Mira they call commands. Basically here in this diagram, the message is now coming down from the client into the server, rather than the other way around as you saw before. So after these right checks for the player's power and spawn position were verified client side, we could then send this over to the server to make this check against the values held on the server, our source of truth. As you can see, we also have quite a large function here in that little code snippet up there, just about 50 lines, and it's all just for the spawn troop check. This is where all of the extra verification for these values is made, and also detailed logs as to why it may have failed or why it's successful. And all of this just so that some schmuck couldn't spawn some troops whenever and wherever they pleased. So after getting through the teething and the tantrums, we could finally focus again on the juice. But with juice comes great responsibility, and there wasn't much light at the end of the tunnel, even after these solid refactors. Which brings us to our next stage, young adulthood, the reality check, where the mistakes we've made and heartache we've experienced have shaped our project into the game it is today. Using this graph here as a visualization for the Dunning-Kruger effect, we can see firsthand how our fate was just destined not to be so smooth. Basically, we as a team, for the most part, knew nothing about making an online multiplayer game, and so we started at the bottom, low confidence and a knowledge of zero. During early development, we quickly and easily climbed up the peak of Mount Stupid as our confidence grew, but our wisdom, not so much. Thus our descent and plummet into the Valley of Despair, which is actually where we find ourselves at now. But there were really some things that really helped us claw our way out of this valley and slowly help us make our way up into the slope of enlightenment. We needed to make sure that, for all people coming in and getting their hands dirty in Unity, that the project was easy and simple enough to come in and not only navigate, but also make changes to. Before we had even started working on the project or doing any research, we knew that we wanted to utilize the use of multiple different environments to ensure that we always had a stable build that wouldn't get tainted by new work being pushed in. For Galactic Islands, we sort of ummed and ahed about how many of these we actually needed, but we finally settled on having 4. Firstly, there's development, a dark place where devs and designers alike can do whatever they please. Then testing, the environment that QA actually tests in to make sure that the work done in development hasn't muddied all the waters. Then there's staging, where when given the all clear, testing is pushed to and is what we use to send builds to the client and for our external playtesting sessions. And finally, production, the bug-free holy grail release candidate. As we did decide to go with 4 different environments though, this made the setup for these actually really quite cumbersome. For all of the plugins we were using, PlayFab, Firebase, Google Analytics, the list goes on. Most of these required for us to make a new project dashboard for each of these environments, which came with their own set of customer credentials and IDs and whatnot. So we needed to make sure that these were all hooked up and set correctly. We also use Unity Cloud Build to automatically make our builds for us, and so we need to make sure that all of the configuration there for the relevant environments, platforms, plugins were all correct, so that, for example, if we made a testing build, that the analytics for that wouldn't be pushed to our production title. We did this by utilizing the power of pre- and post-build scripts, which read from our custom-made scriptable objects, which essentially we use just to store this relevant information and data and like the IDs and everything. We also use custom scripting defined symbols for each of these environments so that when the pre-build scripts ran, they could read off this to detect which was the current environment we were using, and then pull from the script to objects and update everywhere what the actual values should be. And so that when we made builds locally or through Unity Cloud Build, they were created using the right environment settings. The use of these scripting defined symbols really made in-editor testing and switching really quick and effective, and we probably would have been lost without them. One thing which we usually forget to add also, but really try to add early on, is the ability to automatically hook up references. It's really good to expose your serialized fields, but it's also really easy to make mistakes whilst hooking these up sometimes, or sometimes even forgetting completely to do so. This was a big problem for us with all of our entities that we had in the game, as we have heroes, buildings, and troops, which we decided to all inherit from the same entity class, but ultimately they are abstracted out into the different classes entirely to account for their custom behaviors. This meant that we had references and components which, A, all of these entities needed and wouldn't work without, and B, some of them needed and some didn't. Like there's buildings that can attack, and other buildings like gold mines that can do nothing as they are pummeled to death. Or for prefab variants which are specifically used for the battle scene. These needed specific network components which they needed to work with the mirror plugin, that the ones in the island scene we didn't want them to have them attached. In our game, we also have entities that change how they look as they level up, so we needed to try and make this setup easier for artists as well. We did this by adding editor tools so that they could quickly add the required meshes and references when creating these skins for different levels, which we did by creating clever scripts that looked up the names of the right objects within the project's folders within the click of a button. Now I say clever because this is assuming that everybody has named the objects all correctly with the right IDs. So as you can tell, even from that short example there, the code for these usually isn't very pretty at all. But it's a sacrifice you need to be willing to make in order to reduce a hell of a lot of time and heartache so that gold mines just don't start shooting bullets at everybody. Another tool which we now use in all of our projects at Chaos Theory is a custom debug menu. This really speeds up the testing for QA and aids them in not only testing new features but also existing ones, which they can do through the use of custom debug tools such as giving themselves more currency or pausing the battle timer or skipping certain tutorial steps. Pretty much anything that anyone needs throughout development, artists, devs, QA, even other developers, we can add custom buttons for to help them skip these certain things, pretty much just speeding it up to make it less repetitive. It also gives you access to Unity's console and even the profiler on device, which is pretty neat, which means that we can log spikes in performance as soon as they happen, along with a detailed report of what happened and when, and essentially just tell us how to fix it. Due to our multiple environments as well, we also have the ability to toggle this button on and off, so that this menu is only available on builds made in the development or testing environments. So please don't go try touching that top right corner of the game when this comes out. We trust all of you here. We also knew that we needed some form of remote config, a database which would allow for real-time modification of variables in different environments without the need to create new builds every time just to test these changes. If we left these values stored on the device and player prefs, this would mean that people could just easily come in and change these values, and we really didn't want that. So we chose to store this in the form of a Google Sheet, where values could be changed quickly and effectively, and even harder algorithms such as how long does it take to upgrade a building from level 2 to level 3 could be calculated before pulling all of this into Unity. This graph is basically our visualization for how this flow works. You'd start at the top in Google Sheets where all of our values are stored. This would be pulled into Unity Editor, and through the use of our custom game data importers, these JSON blobs would be actually converted into readable C# code. This is then pushed again up into Unity's remote configuration, which is what we actually read during runtime so that these values can update if anybody's made any changes. Again, we got a lot of use out of our different environments here. We decided to have a sheet for each of our environments so that if any tweaks were made in one, this wouldn't affect any of the others. A good example of this is while developers were adding new features to the game on the development sheet, they could mess that sheet up all they wanted whilst not affecting testing being done at the exact same time by QA in the testing environment. It made it extremely easier for us as well to come in and tweak values to balance everything out, but I'll get more into that in a little bit. Here at Chaos Theory, we test our games at least once every 2 weeks, usually in line with our sprint end. This gives us an opportunity to test the whole gameplay loop, and get others on the team who aren't actually actively on the project to give their opinions on how they think the game should be changed or improved. With any game, it's really important that you gather around to test it properly anyway. Yes, we get to play the game while we're working on it, but it's also usually in isolated sections or with the tunnel vision of, oh yeah, this is exactly how I've implemented it, exactly how the jury ticket says it's perfect. But we all know that QA have magic little fingers and find way to break these user flows. It's also really important that we show this game to people who have never played it before, such as having external playtesting sessions, so that you can get the opinions and see how people with no knowledge or experience of the game receive it. Above all, it's also a time where you can just bring the whole team together and discuss the game as a group, to see what people think who don't usually have a say into what goes into the game, thus increasing team cohesion and boosting morale, with also, creating some friendly competition. Other than new features and mechanics, one thing for a PvP real-time game that we wanted to get right was the balancing. With so many buildings and troops and then heroes on top of that, we had to make sure that all the differing values and army combos didn't totally underwhelm or overwhelm these matches. For example, with troops that cost more power to spawn, these felt worthless sometimes and not worth even equipping as they were weak and didn't feel like, as a tanky troop, that they were dealing enough damage compared to other ones which cost less. Also with some new content being added to the game, like our example here in one of our new heroes, Crux, whose ability makes everyone around him invulnerable. When he was paired along with one of the nanobot troops, who duplicate every time that they make a kill, it was just a tram smash. And one playtesting session, those who used this strategy just overpowered and dominated every opponent that they faced. So, with that quality of life tool that I mentioned earlier, we used remote configuration to make these adjustments quick and easy to test. We were able to quickly and effectively rebalance entities by tweaking values in this spreadsheet, which usually immediately fixed the issues playtesters brought up in game anyway. It also allowed us to speedily test different modes which we wanted to explore and experiment with, like should troops even be spawned with power or should they just spawn automatically at your factories? It gave us the chance to really see how this would change the meta of the game and whether or not we wanted to move forward with that new mode or not. It was also a tool that designers could use to quickly try something out and see how that slight change in an integer or float could really impact the pace and feel of the game entirely. Which is where we are at now, a game that we can really be proud of. A game that when we sit down and play test, we're not complaining about not being able to find a match or that our buildings are doing random things at random time. We can have a lot of fun, and I'm really interested to see how this game is received when it finally comes out. But now that I've talked your ears off, I'll throw our project's report card back on over to Will.
So for the final stage of the life cycle, we move into adult life. This is the point where we've had a chance to look back and think about some of the things we could have done better and some of the regrets we may have had along the way. For this section, I'm going to cover some of the best tips I would have loved to have heard before Galactic Islands began and wrap up with where the game's currently up to. So my first tip I've got here is creating controllable scripts. And this is really about separating your data from your functionality. I think this one was a bit of a no-brainer for us in hindsight. It's fairly high level, but we found it really easy to forget this early on. Up here on the left-hand side, you can see an example of some code I think I pulled off a Unity tutorial for a player movement script. You can see it's pulling in the horizontal and vertical axis from the input. It's converting that to a vector and moving a player at a given speed. It's all nicely well contained. It's all there. It does what it says on the tin. You probably wouldn't get any negative marks for writing something like that. But what we needed to do, and we found ourselves doing more often, was what was on the right-hand side. And this is where we bring in the controllable scripts. Up the top, you can see I've got the player script there, and this is what I'm calling the controllable script. It exposes a bunch of public functions that are the meat of what the player should be able to do. This is things like movement, maybe jumping, shooting, crouching, anything that the player should be able to do. But what's important is that on its own, this script does nothing. If you were to attach this to a game object, it would sit there, probably look pretty, but do nothing else. Then we bring in the player controller, which is the one just below it. This is bringing back that level of control that you see on the left-hand side, again reading the input axis from the horizontal and vertical, converting that to a vector and passing it back to the player, allowing the player to do what it needs to do with that, which is essentially the same functionality that we have on the left-hand side. Now, why this is important is because for us, we needed to be able to use our players in multiple different contexts. That player, when we're in a multiplayer scene, you've got the player controlled by the touch inputs, you've got another player controlled by your network events. And so we need some level of control that can be split like that. which brings us down to the bottom section there, the network controller. You can see that there is a similar reference to the player. However, in the update, we're reading network inputs about the movement, forming that into a vector and passing it up to a player, which allows you to capture that meat of what the player is in one place and use it in two different settings, which means that you don't have to re-implement the player when you're in single player and in multiplayer and for player 1 and player 2, and really allows you to dynamically use a lot of those systems without a bit of refactoring. This was the same sort of scenario for our island controller, which was the system that built the buildings on the island that you see. Originally, that was just loading stuff straight out of save data on the island when the game loaded. But as soon as we went to multiplayer, we needed that to be able to read from server data. And so we had to spend time taking that layer of control out, refactoring that, and making it so it could work in multiple contexts. Honestly, there were so many things that this was happening for. We got heroes, abilities, troops, the list goes on. But it's really important to build your systems as if the data could be coming from anywhere when you're endeavoring on this kind of a project. I think skipping this early built a little bit of technical debt over time for us, and that was a bit jarring going into some new features. Sometimes it felt like it was one step back, then 2 steps forward, which slowed things down and didn't have the best feeling for early development. Having this foresight and sort of moving forward, we discovered that by building things in the controllable way first, it was so much more smooth when new features needed to be implemented in the project. Second one I got here is tackling one problem at a time. And this definitely comes for any project with a huge amount of unknowns. A lot of our early development moved slowly due to us thinking about too many things all at once. While you're trying to learn, and we were trying to learn a hell of a lot in this, break down your tasks even more than you usually would. Don't create tickets for get islands spawning in multiplayer if you know that in order to achieve that, you need to create maybe a connection manager, have ways of 2 players joining a server, have ways of downloading those players' data, etc. It's easy for me to say that in hindsight. How can you know what you don't know? But what's important here is as you discover and as you uncover those things as you're going along, you don't try and keep them in your head. If you're using Jira, Trello, or even stickies on a whiteboard, write those things down, put them aside, and focus on what you need to focus on as the next smallest unit of work. It's really easy to get overwhelmed by setting yourself goals that are too far into the future, and it definitely will slow you down. Work slowly, plan ahead, and know what your next problems to solve are, rather than trying to solve everything all at once. Sprint planning sessions, if you're running sprints, technical planning, if you're into that kind of thing, or even pair programming are really good tools to use to help mitigate some of the issues that we have found here. Another one that I've got is don't silo. Try and get everyone familiar with different parts of the project. I think of the 5 developers we had on this project at the start, we organically split up into maybe a couple on multiplayer, one on single player, one on some core systems, another on UI. The single player, however, was very entwined with the multiplayer. There was a large degree of crossover between those scripts. Those buildings that you see on the island are pretty similar to the ones that you're seeing in multiplayer with just a bit of a network layer on top of that. People working on single player would frequently build their systems and test their code within the context of single player, because that's what we were really used to, was single player games. This often, as you can imagine, had real flow-on effects in the multiplayer side of things. Make sure early on that everyone knows what is required for network code to work and how network code can be tested. It's very different to single player. You're building clients, you're building servers, you're forming connections between the two. It's a different beast, and if you don't know what you're getting into, it can be a bit messy. This upskilling, though, I think is really great to do through pair programming. The nuance and the communication that you get through that pair programming with someone who knows what they're doing versus someone who's upskilling is super valuable, and I would definitely recommend that you do that. But it's important, definitely, to get everyone's hands dirty in the network code. It makes knowledge sharing so much easier, builds developer empathy, which is super important, and reduces the bust coefficient of the team. And for those that haven't heard that phrase before, it's essentially your key person risk. Over this 12-month period, people are going to go on leave, they're going to get sick, maybe they'll move on to other things, and that will create a void in the project's sort of knowledge base. Having other people being able to fill that quickly and easily is going to reduce a huge amount of stress that your team feels over that long term, and it's just going to make the team happier in the long term as well. So reducing that is definitely in pretty much everyone's favor. And my last tip that I've got here, it's a quick one, is building a smoke test plan really early on in the project. A smoke test plan is kind of what your game needs to do in order to be working at its most fundamental level. For us, this was going through the loading screen, loading the island, getting into a multiplayer match, probably with yourself, finishing that multiplayer match, and returning back to the island scene after you're victorious, which sort of forms that core game loop that you can see. You want to document this plan, make sure all your developers, your producers, your designers, literally everyone knows it and is aware of it and can practice it. Devs should be covering this smoke test even if they're working on features outside the core game loop, probably especially if they're outside the core game loop, because that tends to be where most people get blinded to, oh, my code's not over there, I probably didn't break it. And this just makes everyone's life happier, trust me. So after all that, where does that leave us? Galactic Islands has come a long way. It's still growing as we speak. There's some more exciting things to add, but we're getting pretty close to a soft launch at this point. As a side note, if you are interested in taking part in the soft launch, please feel free to reach out to us and let us know, and we'll try to include you. But that's a wrap. We'd like to thank everyone for coming and listening, and hope you learned something along the way. And I believe we've got a bit of time for Q&A now. We're a bit ahead of schedule.
Hey guys, I'm curious why you'd go with Firebase for your cloud functions if you're using PlayFab instead. So why wouldn't you go with Azure functions?
Yeah, good question. We had when we were looking into PlayFab, the Azure functions were very much on the rise, and PlayFab was still pushing their PlayFab cloud script, which was a really old-fashioned JavaScript only, very limited source control system. The Firebase cloud function allowed us to host our repo locally and just push up using some command line tools. I know that Azure can do that for you now, and we probably could have used Azure. However, there were some other features with Firebase that we knew we were going to be using down the track, such as Firebase's real-time database we ended up using for our guild chat system, and yeah, some other things like that. We're also probably just more familiar as a company with Firebase. But that's not to say that you couldn't have used one or the other. Ultimately, they both are cloud function providers.
Hello, great job on the game. Testing and maintaining a multiplayer game is not easy at all.
Thank you.
I just wanted to ask about the Mirror RPCs. So I haven't used Mirror before, so I don't know exactly how that works. But you mentioned you were sending an integer to every client, at least once a second. Mm-hmm. Yep. Did you do any bit compression on that integer?
So Mirror under the hood, their kind of mentality or selling point is let us think about the networking, which for us was really good. I do know that under the hood they're using protobuf, I'm pretty sure, so they are doing a bit of bit compression themselves, and they're sending things on an interval, but it's not something that our layer of the code really deals with. And so we did reach out to them early on for some support like this, and generally their response is that's kind of on us. We are doing it. We are doing best practices, and you just have focus on the game. But they are doing some of that. We specifically weren't.
Yeah. And just to clarify, that's not sending the whole 32 bits if you don't need the whole 32 bits kind of thing.
Pretty much, yeah. Yeah, exactly.
Awesome, cool.
I was just curious to hear more about how you implement pair programming.
Yeah, good question. So it's definitely something that's a cultural thing at our company. We've got a lot of people of various skill levels. We run sprints generally. We've been running sprints for this project on a 2-week cadence. And during sprint planning, if there's anything that seems like it's a chunky task, or there could be some onboarding or some knowledge sharing involved in it, we kind of say, oh, this is a good candidate for pair programming. It's something, and when you do that, essentially it's two people, either they're sitting next to each other in the office, or they're sitting on a Google Meet call together, running through the code, doing some screen sharing, and solving that problem together. We try to do this at least once or twice every sprint to make sure we've got a culture of that. And we found that generally everyone on the team is a huge advocate for it. I think it gets sometimes a bit of a bad rap of like, why do 2 devs when 1 dev do job same? But but ultimately you learn so much and people seem to get so much out of it. There's just this great camaraderie, I think, that having your devs work together, we are a team, so it just really helps in that regard. Does that kind of answer your question, or were you looking for more the technical side of that? Yeah, fantastic.
Just adding on to that, how was that moving into like a remote working situation?
It was challenging. I think we had a lot of challenges going remote. One thing that I think was an absolute fantastic tool here, super niche, but like a lot of people here use Slack. We use Slack for our communication. Their screen sharing tool has the ability to draw on the other person's screen. And while in person, you can be like, that line of code there, it breaks down when you're on a video call. And being able to just be like, this thing right here, that needs to change, or the bug is there. If you can find a tool that works for you, Slack's screen sharing is great for that. That is fantastic. I don't think we would have continued it if we didn't have some way of communicating in that regard.
Just in, might be a hard question to answer, but in hindsight, would you use any of the other alternative plugins for any of the networking stuff, or is that a hard question to answer?
I don't think so, no.
Are you happy with how it went?
Yeah, but that might be that we've just come to know it so well, and I don't we did dive quite deep into the other ones, but ultimately the ones that we've chosen have been able to provide us with a bit of work, everything that we've sort of needed. I think there's another one up the back.
Hi, nice talk and congrats on the game.
Thank you.
This is first a bit of a comment. So when we did sort of our tip, when we did Crossy Road Castle, 4-player co-op, probably the single biggest productivity thing, I think if you're considering developing a multiplayer game, is to have a build that you can basically embed the server and all the clients in the same process. So you can use the same Unity editor instance or whatever tool you've got, and avoid singletons in your code so that you can actually spawn isolated clients. And so we had an environment where we could create 4-player split screen within the same process and create and destroy clients at will. And then you can put all the simulation of network disruptions and stuff within the same instance. And that's just super, super powerful, because then you can debug and step through code and find, any problems there. So that's just,
fantastic.
And then a question, it sort of looks like the game is comparable to the genre of like RTS and MOBAs. And had you considered a lockstep deterministic model where the client and servers were essentially taking the inputs and then running a deterministic simulation to reduce the bandwidth? Was that something you'd considered?
It was definitely considered. Of the many documents we wrote, I think there is one that is actually on lockstep. It's been a while since I've looked into it. My memory was it felt like at the time that it was going to be a lot to bite off. And as we sort of had like limited network experience, there definitely, I guess the caveat may be better ways of doing some of the things here. RTSs in particular, I know that's a really big recommendation, is to use some sort of lockstep simulation, which seems great for those. I guess what we wanted to be able to do was something that would like get us to the result. And a lot of why we chose what we chose was for the team's benefit as well as the project. So maybe there was a bit of a sacrifice there, but it was considered. But we didn't ultimately go with it.
I think that's time. Thank you.
Thank you so much, guys.